Okay, this is a video for 8.3G, arcs, determining missing and congruent arcs. So, in the last video we talked about identifying arc measures, and we said that they were equal to the central angle degree measure in this circle. That will be similar to what we talk about today. We're just going to take it a couple steps further. But let's start with sort of a review of what we did last time, and we'll look at problem number 1. Problem number 1 wants us to find the arc length of KL, or the arc measure of KL. Here's KL right here. Since its central angle is 60 degrees, KL also has to be 60 degrees. So we know that the measure of arc KL 60 degrees. Same idea can be applied to 7. But now let's take a look at problem number 11. This one wants us to find the measure of ML, arc ML. And we don't know the central angle. And so since we don't know the central angle, we can't immediately know the arc measure. But we do know the measure of NM, which is 55. We know KL, which is 60. And we know that NK, this line right here, or KN, is a diameter, which splits this circle in half, because it tells us in the instructions. So we know that this entire measure, all the way around from N to K, has to be 180 degrees. So if we take 180 degrees and subtract 55 and 60, it'll leave us with this measure right here, which is what we're looking for. So 180 minus 55 minus 60 equals 65 degrees. So the measure of arc ML is 65 degrees. Now let's take a look at a couple more. Let's do problem 16. This wants us to find the measure of arc HIJ. HIJ is this major arc right here. It's a major arc because we know it's more than half the circle, so it's going to have an arc measure of more than 180 degrees. Now, we know that HI, which is this piece right here, is 130. And the other piece, IJ, is 80. So if we add those two together, we will get the measure of arc HIJ. 130 plus 80 equals 210 degrees. So the measure of arc HIJ is 210 degrees. Alright, flip to the back of your page and we will do two other problems. Now let's take a look at 22. This problem wants us to find the value of x. So not an actual arc measure, but using arc measures, let's solve for x. Well, we know that BC is 2x minus 30, and we know that AC is just x. And we also know that those two added together has to be 180 degrees because this is a diameter, so BCA is a semicircle. So let's add those two things together and set it equal to 180 and solve for x. 2x minus 30 plus x equals 180. Combine your like terms. 2x and 1x is 3x minus 30 equals 180. Add 30 to both sides and you get 3x equals 210. And divide by 3 and you get x equals 70. And that is our answer for that one. Alright, finally, let's take a look at 26. We talked a little bit about congruent circles and arcs in a same circle and whether the arcs are congruent or not. So, they want us to see if arc RS is equal to arc AB. Well, the first thing to notice is these are two separate circles. So for those arcs to be congruent, because you can see that these central angles are congruent, but for the arcs to actually be congruent, those circles have to be congruent circles, or the same size. Looking at the radius for circle 1, that's 7 millimeters. For circle 2, it's 4 millimeters. Since they have a different radius length, these are not congruent circles. And so even though the central angles are congruent, these will not have congruent arcs. So RS is not congruent to AB, and it's because the circles are not congruent.